Okay, so these notes that we took in class over covalent nomenclature are on pages 3 and 4, and then there's a little bit of practice on page 5 that I'm going to need you to do. But before we even get into the complicated rules of how to name covalent compounds, you should know that there are going to be different rules to name ionic and covalent compounds, and part of that comes down to the differences in the types of bonds that they have, and that determines some differences in the compounds that they can make, some of the rules we have to name those compounds. So it is important to remember that our covalent bonds form when electrons are shared between non-metal atoms. And that sharing can happen in a lot of different ways. If you think about like sharing candy with your siblings at Halloween, you could share by swapping candy with them, like trading 1 for 1 or 2 for 1 if you like one thing more than the other. Or you could even just give your sibling the candy you don't want. That's sharing, right? There's lots of different ways to share that can still make everyone involved happy and happier than they were before, even though they're, not all quite the same. And so the same thing is going to happen with these non-metal elements. We can have compounds between the same elements, like carbon and oxygen. If it's CO2, we can be breathing that out all the time, that carbon dioxide. But we can also have CO, just one C and one O, and that is carbon monoxide. And notice how we use some prefixes. Di, mono are prefixes that you probably see down there at the bottom of this page. And because they can form different compounds, we have to use prefixes to tell the difference between them. We called both CO and CO2 carbon oxide, we would never know which one we're breathing out and which one we would die if we breathed in even a little bit of. So prefixes are going to be important for covalent, but we're not going to use them at all for ionic because ionic can't have these different combinations of the same elements together. So that's just an example of how those properties of our electrons and our compounds come into these nomenclature rules. That's why we taught you that stuff first. And still, even before we get into the naming rules on the next page, there are some simple covalent compounds that don't follow all those complicated rules that you need to be aware of. And the first one is ammonia. I'm never going to ask you a simple question like, what's the formula for ammonia? But it's such a common molecule, you probably even have some under your sink at your house, and it's used for cleaning a lot, that a lot of people just assume people know what it is. So I've seen the CBA, the district people in the past just say, write the Lewis dot structure for ammonia without telling you that it's NH3. So we need to work on you being more familiar with that so you're prepared for those types of questions that other people might throw at you. Now, the rest of these are not really complicated formulas like ammonia is. They're what we call diatomics. And what diatomics are elements that can't go anywhere without a buddy. They have to be bonded to another atom. And it can be an atom of a different type, but if you get them all away from other elements, if you just had a container of oxygen, just pure oxygen, you wouldn't find a single atom there anywhere. You would find pairs of atoms. And you probably know from biology that oxygen is O2. It's not just O, like the periodic table just has an O there. It's because it's so unstable, so reactive on its own, that it's going to grab onto anything that it can. So you need to be able to recognize these 7 diatomic elements. And there's a couple of tricks to remembering them. There's 2 different sayings that I remember. And the first one is, I bring clay for our new house. And that is a silly, kind of random seeming saying, but the first letter or letters of each word are the symbols for these 7 diatomics in the periodic table. I for iodine, Br for bromine, Cl for chlorine, F for fluorine, O for oxygen, N for nitrogen, and H for hydrogen. So you can get all of those with that one saying. If that's too long for you, then there's this other Sprinkelhoff word. It's not really a sentence or a saying, but it's just kind of a funny sounding word. Kind of sounds like Hasselhoff to me. But that just has the symbols of these 7 diatomic elements. They're in a slightly different order, but they're all there. And if you can remember Brinkelhoff, write that down on a test, you can remember all 7 of the elements that are diatomics. And There will be a question on your test eventually that asks which of these elements is a diatomic. Straight up, you need to know these. So we'll start working on it now. It will be crucial later in the year that you remember them, but important a little bit now. So what we're going to fill into these blanks is actually the names and formulas. When we see Cl2, it's not dichlorine. We're about to see that prefix di means 2. And in all of our other covalent compounds, we will use di anytime we see something with a 2 on it, but not here, not if it's just Cl2. Cl2 is just chlorine. F2 is just fluorine. Br2, bromine. I2, iodine. And just like I said earlier, if we're talking about breathing oxygen gas in, it's O2 gas we're talking about. Hydrogen gas, H2. Nitrogen, N2. We don't have to say the word gas. That's not what means put the 2 on it. It's the fact that that element can't go anywhere by itself. It kind of reminds me, and I don't know why it always seems to be girls, but those girls who can never go anywhere by themselves. They're like, hey, I need to go to the bathroom. You want to come with me? Hey, I want to get a cookie from the lunch line. You want to come with me? Hey, I need to go to my algebra teacher for tutorials. You want to come with me? It's like they can do all of those things by themselves, and yet they're more stable, more happy, more whatever with a buddy. So some elements are like that too. So moving on and to get started in the beginnings of our covalent nomenclature. I mentioned we're going to use these prefixes to tell us how many of each element there are in a compound. So you kind of need to memorize these prefixes. And a lot of them are prefixes you've probably seen maybe in geometry, like hexagons for hexa, octagons, maybe even pentagons, decagons. You've probably seen and heard tri all over the place. Triangles, tricycles, and maybe even mono some places as well. Like a monopoly is a single company owning all of a certain type of resource, or monotheistic is the belief in one God. So mono is somewhat common, but some of these others are a little weird. A lot of people try and use bi for 2 instead of di, and I know that it might seem weird and random that they chose di instead, but if you remember carbon dioxide, which hopefully your biology teachers got you to remember that last year, is CO2. That's one of the best examples of covalent nomenclature and all the rules we're about to talk about. And so that can remember. CO2 is carbon dioxide, which helps you remember di is 2. And tetra is also kind of a weird sounding one for 4. You might have thought it would be quad or something. But if you think about tetra, probably sounds like Tetris. And Tetris shapes, even though they're all different shapes, are all made out of sets of 4 blocks. So that is where that prefix, or where the name Tetris came from. It's that prefix. And then hepta is also kind of a weird one. What I remember is it's kind of like hexa, but a little bit bigger. So it's basically 6, just 1 bigger. And then nona almost sounds like 9, but sometimes it's hard to remember. So I know that these 3 prefixes are probably some of the hardest ones to remember. So you can basically be guaranteed you're going to see all 3 of them when you take your quiz and your test in the future, because I am definitely going to test you on those. So start working on memorizing these however you need to. Just practice them. We're definitely going to be seeing more of them on the next couple pages of notes, but also in our tests. So be ready for it. Feel free to flip back and check this page for those prefixes until you get comfortable with them. Now, we're going to jump to the next page and talk about all of this stuff that I was just putting here. It's just kind of a preview, and I've mostly said all of these things already. So let's actually just jump to that next page at the top. What are the steps, the instructions for how to write a covalent name? And really what it comes down to is that general idea I've already mentioned. We are going to put a prefix in front of each element's name in a compound. So if I'm looking at something like CO2, I've got to know the name for C and O, and then I've got to know the prefixes that tell me how many C's and O I have in that formula. And then, as you've probably noticed, that last element, it's not carbon dioxygen, it's carbon dioxide. We change that second element's name to have that "ide" ending, whenever it forms a compound. So this is going to be a little bit weird to get used to, but all of those non-metal elements that are going to be at the end of our compounds, and there's only like 10 or 12 of them, you need to get used to shortening and simplifying their name to having that "ide" ending. In fact, since you're not in class necessarily to do this with me and get my help with it, I want to make sure to go over these real quick. There's not that many of them. These are all the nonmetals you might possibly need to change into the "ide" form. And for the most part, you are just taking the first syllable and then dropping the rest of it and adding "ide" to the end. So our hydrogen, if we take the hydra part, turns into hydride. Boron, boride. Carbon turns into carbide. Nitrogen, nitride. Oxygen, of course, is oxide. Fluorine turns into fluoride, like the stuff they put on your teeth. Silicone is kind of a weird one. It's silicide or silicide there. Phosphorus, I know it's a long name to begin with, but we just take the first syllable, phospha, and add the "ide" on the end. So phosphide, sulfide, chloride, selenide, another one you probably won't see much of, bromide, telluride, definitely not one you're going to see or use much, iodide, and astatide, also kind of a weird random one. That one we actually kept 2 syllables in, so just be aware of what they are. You don't have to write them down necessarily, but you can come back to this slide if you're getting stuck on some of those example problems in the future. So jumping back into the notes, there's this little side note here, and it's not really that important. I'm not sure how it ended up basically on here twice, but instruction 3 and 5 are basically saying the same thing. And this isn't like mandatory, but you remember that carbon monoxide example? Well, we have 1 oxygen there, but we didn't say monoxide. We just said monoxide. Because that would have 2 O's in the middle and would maybe look a little bit like monoxide, which is very silly and not real. So they dropped that extra O just for kind of simplicity's sake and for the sound of it. But if you write monoxide, that's fine. I promise not to judge you or take off any points there. The one thing that is really important, especially about that mono, is that mono is never going to go in that first prefix space on the first element only. It can and does absolutely go on the second element, like we see here in monoxide. Totally okay there. It's just that so many compounds start with a single atom of that first element that it'd be mono this, mono that, and no one wants to get mono anywhere, let alone all over the place. So drop the mono on that first element, even if there is just 1 atom of that first element. So, moving forward, no, you don't need to fill that in there, sorry. It's just the key example that I keep coming back to. If you can remember carbon dioxide is CO2, that has all of these rules in there. So let's do a couple of these practice problems together, and you really just need to focus on kind of decoding, translating each of the element, the kind of halves of these element and compound names. So carbon is C. Disulfide, well, I can see that di prefix that I know means 2, and then sulfide, remember that "ide" ending we added. So if I'm thinking about elements that sound like sulf, that's going to be sulfur. So I have 2 sulfurs, and we just need to remember to put the 2 after our element symbol. That's the spot that belongs to prefixes, or the number of atoms of that type. So we've had kind of numbers that we've put on every other corner of an element symbol, and now this bottom right-hand corner is where we put the number for how many there are. So carbon disulfide, all together, just CS2. Sulfur trioxide, well, sulfur is S. Trioxide sounds like I have 3 oxygens, so we're going to make that O3. Diphosphorus, P2. Trioxide again, O3. Carbon, just C. Tetrachloride, got 4 chlorines there, so CCl4. Dinitrogen, N2. pentoxide, O5. Dinitrogen, again, N2. Trioxide, O3. Another example of places where we can have the same elements bonding in different ratios. We've got lots of different nitrogen-oxygen compounds and lots of different ratios. So we've got to use these prefixes. We cannot just call them nitrogen oxide because they're all different forms of nitrogen oxide. Then trisulfur, S3, non-oxide, O9. And then iodine, monobromide. We probably didn't worry about it before when we had these elements that were just one carbon, one iodine. We didn't write anything else, but it kind of made sense since we just had carbon in the name. But even here, when we have monobromide, telling us we have one bromines there, we gotta have the mono prefix in the name, but we never write ones in the formulas when there's just one atom of an element. That is just not done. It kind of looks like commas, and if we wrote the element symbol, it's obviously got at least one of them in there. So just IBR, no ones included in the formula, ever, 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 no matter if the prefix mono is there or if it's not there. Don't write any ones. Then tetrasulfur, 4 sulfurs, dinitride is going to be N2. So these are pretty quick. I know it seems kind of repetitive, but the more you do these, the more fluent you're going to get at the language of chemistry, and everything else is going to be way easier. Now, I know your lines are not as long as my lines. You're probably going to have to run off the end of your lines. But decoding and writing a name, while longer, is not any harder. You just need to remember that even though the number is after the element symbol, that we turn it and flip it and it becomes a prefix, a word before the element's name. So when I have P3 here, I have 3 phosphoruses. So that's going to be triphosphorus. And then O8, I have 8 oxygens, and I like to just say that to myself so I can move that number word up front. 8 oxygens turns into octaoxide. Remember here that every element at the end of the name is going to have its name changed to have an "ide" ending. So next one, 2 carbons, dicarbon, 6 sulfurs, hexasulfide, 2 nitrogens, dinitrogen, 4 hydrogens, tetra is 4, and then remember hydrogen turns into hydride. CO2, we probably don't even need to turn on our covalent nomenclature rules. Hopefully we recognize that is carbon dioxide, but remember, no mono on the first element. Use di to say that there's 2 oxygens there. Cl2O7, we've got 2 chlorines, so that's going to be dichlorine. 7 oxygens, heptaoxide. 4 arsenic turns into tetraarsenic. 6 oxygens, hexaoxide. 1 iodine, 1 fluorine, so that's going to be iodine. No mono at the beginning. We don't use mono on the first element, but we do put mono on that second element. So that's it for the notes. I would like you to go ahead and try some of these practice problems here. We're not going to take a ton of time to do them, but you could probably knock out some of them in class if you need help. But I'd like to see what you can do and then ask for help when you need it. The one thing you really need to make sure to fix is right here. It says Cl4. I need you to change that to Cl2. Hint, that's one of those diatomics we saw earlier, so don't get carried away. There's actually no di in that name there. Go back and look at your beginning of this podcast if you're not sure what I'm talking about.